Hello everybody, it's me Sebastian, and today I'll be explaining a number theory problem. So the statement is such: find all primes p and q such that p plus q is equal to p minus q cubed. So let's begin. First of all, let's consider the first case actually, where p equals to q. This is quite trivial that this doesn't work because p minus q would be 0, and therefore p plus q is equal to 0, which is only possible when p and q are equal to 0, and 0 is not a prime number. Therefore this won't work. From this actually we can deduce the fact that p and q are coprimes. Now what can we do with that property? Well, we could use modular arithmetic. Let's consider a case p minus q mod p plus q. This is actually congruent to 2p. That makes sense, right? Because if you move 2p on the other side, then this would be minus p minus q, and if you take out the minus, it will be minus p plus q, which is divisible by p plus q. So that makes sense, right? Also, we actually want p minus q cubed, therefore we can cube both sides. Let me actually do it right here. Here, p minus q cubed. This will become, cubed. And here, this will become 8p cubed. That makes sense, right? Now, I also want you to notice that p minus q cubed is equal to p plus q, which is congruent to 0 mod p plus q. Therefore, 8p cubed would also be congruent to p plus would be congruent to 0 p plus q, mod p plus q. Therefore, 8p cubed mod p plus q is congruent to 0. It makes sense. Now, I want you to notice our initial statement that p and q were coprimes. Now, you also have to notice that p and p plus q are coprimes because let's consider the case when they're not. So GCD of p and p plus q must be some d. We also know that GCD of p and q is equal to 1 because we said that they're coprime. Now notice that if GCD of p and p plus q is d, then d divides p and d divides p plus q. But if d divides p and d divides p plus q, then d must divide q. And if d divides q and d divides p, then GCD of p and q must be d, but that's not possible unless d is equal to 0. So therefore d is equal to 0, which means that p and p plus q are relatively prime to each other. Okay, so if they're relatively prime to each other, then p cubed and p plus q would also be relatively prime. From here, we can actually deduce a very interesting fact. If 8 times p cubed is divisible by p plus q, then that means that p plus q divides 8 because it cannot divide p cubed or have any factors, common factors with p cubed because they're coprime. Therefore, we can say that p plus q divides 8. Now we have a few cases, which is where p plus q is equal to 2. So case 1 is p plus q is equal to 2. Case 2, where p plus q is equal to 4. And case 3 is where p plus q is equal to 8. Now it's quite trivial that The first one is impossible. Same with the second one, because you cannot find the prime numbers that satisfy these two. Therefore, we're left with the last case, which is p plus q is equal to 8. We have two cases here. Either the answer is pq is equal to 3, 5, or pq is equal to 5, 3. But one of them won't work, because if you actually substitute this into the original equation, let's say the first one, this will be 3 plus 5, which is 8, and 3 minus 5 cubed is minus 8. Cubed is minus 8, and that's not true. So the first one doesn't work, but the second one actually works. If you substitute this is 5 plus 3, 8, and 5 minus 3 cubed is 8. So our answer is these prime numbers are 5 and 3. P is equal to 5 and Q is equal to 3. That's it. Thank you.